Well, I want to warmly welcome you to the 2007-2008 Robert D. Clark Lecture in the Humanities, sponsored by the Oregon Humanities Center. I'm Steve Shankman, the Center's Director, and I'd like to express our gratitude to the family of the late Bill Bowerman for endowing the Clark Lectureship, and we're very pleased to have with us today Bill's son and daughter-in-law, Jay and Teresa, here. It's great to have them. Thanks go to the staff of the Humanities Center, always do an incredible job in organizing events like this, particularly to the Center's Associate Director, Julia Hayden. The lectureship is so named to honor former University of Oregon President Robert D. Clark's scholarship and service to the university. And speaking of kin, we have Bob Clark, who is a dear friend of ours and of the Center's. Ginny Rich is here. Ginny, would you, sorry to do this to you, but it's great to have you with us. And so I just want everyone to know how much we revere Bob's memory, and we so much appreciate the support of the Bowerman family for this event. And I also would like to thank the Oregon Humanities Center's endowment for public outreach in the arts, sciences, and humanities for also contributing to make this lecture possible. So just a bit on the lecture so you have some history of this event. The Clark Lectureship was founded in order to promote discussion of the natural sciences, Oregon history, and the interface between science and social and cultural affairs, as exemplified by Thomas Condon's life and work. You all are aware of Condon Hall. He was a great person, and Bob Clark wrote a wonderful book about Thomas Condon. And so I'd also like to encourage you that if you would like to ensure the robust continuation of the Clark Lectureship, please consider making a gift earmarked for the Clark Lectureship Endowment Fund. And you can find appropriate envelopes on the table in the back. And Melissa Gustafson is pointing to where they are.
Right outside.
Yeah. Our 2007-2008 Clark lecturer is Stephen Schneider, whom we're very, very happy to have with us. He's just been a delightful guest, wonderful to get to know him. He's a world-renowned researcher on climate change and global warming. He's professor of biology and environmental studies at Stanford, and his daughter is a graduate student here, and she's here, so thank you. We have a lot of family with us here tonight. The whole mishpucha is here all over the place tonight here. Professor of Biology and Environmental Studies at Stanford, where he's also the co-director of the Center for Environmental Science and Policy. He's an active participant in the Intergovernmental Panel on Climate Change, the scientific group that shared the 2007 Nobel Prize with Al Gore. And he has served as a consultant for federal agencies through the last 6 presidential administrations, but it's not his fault. He's done what he could. I can tell you, I've talked to him. Absolutely. Steve Schneider is a MacArthur Fellow and a member of the National Academy of Sciences, a founder and editor of the journal Climatic Change, the author and editor of a number of books, including Climate Change Policy, a survey published in 2002. Please join me in welcoming Stephen Schneider, who's going to be speaking to us about global warming. How do we manage the risks?
Thank you very much, Steve, and I want to thank the Bowermans for endowing this. It's a great honor to be here doing the Clark Lecture, and we appreciate it. And those of you looking at the envelopes, do not make that decision based on what you hear from me, based on the previous speakers, right? Okay, what I want to try to do today is sketch out a very broad-scale problem which has to do with humans embedded in a natural system, the climate system, that we both depend on and influence at the same time. And the issue is, how do we, as I put in the title, how do we manage the risks of our use of the atmosphere as an unpriced sewer to dump our tailpipe and smokestack wastes, our land use changes, because that feeds back and changes the very atmospheric envelope and oceanic processes and ecological factors that we depend on. And in the process of trying to improve our standards of living and improve the lives of human beings, we generate side effects which then threaten that very viability that we're trying to improve. So what we're talking about is trade-offs between activities that are not done for the purpose of messing up the environment, but to improve the economy and improve our status, but have side effects. So how do you make those trade-offs? And I want to address that. I'm not going to immediately assume that everybody agrees that global warming is a massive problem. I will spend a little bit of time trying to convince you that there's a high enough probability of that we have to act. And that means there will be some technical slides, and I hate doing that, you know, at 20 to 8 after dinner, especially for those of you who had a nice glass of Willamette Pinot. But I have to show a few so that you can get at least some idea of the problem, and then we can discuss this question of management. So let me begin with one of those. Sorry, I'm going to start with a pretty complex one. So there we are. You know, it's a cute one. The jury is still out on climate change, but I'm not showing this to you because of the fact that people are always saying the jury is still out. It's because you can't communicate anything complex like climate change or defense issues or education or many health issues without using metaphors that people can understand. So let's start with the metaphor that's up there. The jury's out. So jury is a legal metaphor for a trial. So if you're on a jury and somebody's accused of a crime, the judge is going to instruct you on what the standards of evidence should be. And what would that be for a criminal case? Beyond a reasonable doubt. Now, who wants to know or tell us what's the probability of a reasonable doubt? Not defined. That makes scientists very uncomfortable. Because what we do is when we use words like likely or high confidence, we have numerical scales against which we calibrate it, not because everybody agrees that something is likely, but because at least when we use the same word, darn it, we should mean the same relative likelihood. So it makes me nervous to think about that. So I asked my lawyer friends, if there were 1,000 trials, how many would the answer be wrong? They don't like thinking about it that way. And they said, well, I don't know, 900 to maybe, in the bad case, to maybe 999. I said, I hope it's not a capital case. But somewhere between 90 and 99.9% represents beyond a reasonable doubt. So climate is a complex thing. It's a very complicated system. There are very few things that are absolutely certain at a 99.9% level. A criminal trial is a really bad standard. What's the other kind of trial? Civil, standards of evidence.
More likely than not.
Right, preponderance is the word they use. And it's more likely than not, which last time I checked is 51% or more. Now, if it's 51%, then for the last 20 years we've had a preponderance of evidence that's convictable on a civil standard that it's warming and that humans are responsible for the recent part. And I'm going to show you later some details. So what happens out there in the world is that people who don't like the idea of policies that hurt their special interests, their industry, or that don't believe in controlling entrepreneurial rights, they use criminal standard arguments about, oh, but I've got a piece of data which doesn't fit the mainstream, while ignoring all the thousands of bits of data that do. It reminds me, remember the American Tobacco Institute, which for 30 years would cite the 3 studies which were equivocal or showed no connection between smoking and cancer, while ignoring the 300, and then claiming that until those 3 studies are refuted, we shouldn't do anything because we're not proving it. That's not how you do it in the case of a civil trial. And in fact, the standards of evidence even get exceeded for those of criminal trial. Now, I'm sure the artist meant all that, when he did this picture. But we need to do this first because it's really necessary for you to get some sense of it. Because without having that understanding, you get completely fooled because there's all kinds of nonsense. There's a meeting going on in New York right now with the so-called climate contrarians, the skeptics. By the way, I am strongly in favor of skepticism on climate change and every other bit of the intellectual world. Skepticism means let's take a look at every aspect and see where the picture doesn't fit and so forth. There's a big difference between skepticism and being a denialist. A denialist is somebody who doesn't believe that the preponderance of evidence is sufficient basis for having action. We have to have every last detail. Well, that's not how we do it in investment banking. That's not how we do it in medical practice. It's certainly not how we do it in military defense. So why should it, I won't unpack that any further right now, but why should, since you already did, why should this subject of environmental science and policy be 99% or 99.9% objectively sure when everything else we had John hunches and have jury trials with lower likelihoods than that? So all I'm trying to say is you can't let the latest piece of data, which if an enterprise institute says, oh, it's the coldest winter we've had in 20 years, this does not disprove global warming despite their claims, nor if a deep ecology group says, and last year had the hottest, lowest level of sea ice in the Arctic, that doesn't prove global warming either. What you have to do is look, it's global, large scale, long term. And short-term stuff is so easy to get confused. Now, the media is very, very keyed to local short-term. So it's a disconnect between the way that media often tries to report on things that they think their constituents and their readers or their viewers are interested in, which tends to be what's the latest, and the fact that this is a problem where it's accumulation rather than where it's any one new bit. So we have a real challenge, and I would argue that that challenge is, can democracy survive complexity? Because what climate change represents to me is a prototypical socio-technical problem in which you're not going to have honest people telling you every component is solved, and therefore, can we deal with the components that raise high risks? And we'll get to that. Okay, now that I got finished with the technically complex slide, let's move on and remember. Oh, before I do that, remember James Carville? He was an advisor to Clinton. And when Clinton was running for president, remember what he told him? It's the economy, stupid. Right. So that's the whole point of this. If you remember nothing else, remember that you can't get knocked off your pins by somebody citing data that nobody's ever heard of out of some probably not even refereed article, but even if it were, one piece of data doesn't trump 1,000. That eventually it might, but never in the beginning. And in fact, data isn't even information until the community spends a lot of time trying to winnow it out. For example, those famous climate professors, you know the two, they've testified in front of Congress, the experts that they are for all the various publications they've had in the refereed literature. You know the two professors, Limbaugh and Crichton? And those two, they always pointed out the satellite, there is no satellite, there's 10 of them, and they go in a sequence and they have some very little overlap, has shown that the atmosphere is not warming, and therefore it has falsified the surface thermometers. But it's not just surface thermometers, it's surface thermometers, melting mountain glaciers, plants and animals moving around so that the plants bloom earlier and birds come back earlier on migration and so forth, the work that Terry Root just presented to some of you in the last day. And that kind of stuff is all consistent. We knew the surface was warming. So how could the satellite not do it? It turned out, and this is why data is never information and you should never allow a preponderance to be knocked out by something new, is the satellites fly in a soup of protons, right? Emissions from the sun, cosmic rays, that kind of stuff. They're very, very thin. You think of the upper parts up there of space as a vacuum. Well, it's not a perfect vacuum. And the protons that it hits are just enough dings that it slows the satellite down. Well, if you slow something that's spinning around, what you do is you lower its orbit a little bit. That changes the angle at which the sensor looks through the atmosphere, which entirely changes what it sees. Therefore, for 20 years, the community misinterpreted the meaning of the satellite sensing of the emissions of microwaves from oxygen atoms, which is what it measures. And then eventually, when you corrected for the height of the orbits, the satellites now agree with the surface thermometers to a very tight factor. So it took 20 years to falsify the falsification. Now, there's going to be more of that. I'm not saying there won't be something which over time will eventually prove to make us have a different conception, but it's almost never immediate, and that's not a very media or political worthy story. So when we get to managing risks, we're going to have to remember that this is a slowly evolving issue, and that issue requires a lot of expert judgment on the relative importance of how to deal with it. Okay. I like this cartoon for a few reasons. One is that there's been a lot of rewriting of science, and cartoons are a very cute way to do things. They're not always fair and balanced. There are others which I'll show you later go the other way. But here we have the great iconic symbol of the North, the polar bear, which generates a lot of sympathy because of its plight in the melting Arctic. By the way, anybody ever been up there and seen polar bear? I hope you weren't too close. The thing I remember most when I was up there on the ice on a cruise, there was a Russian icebreaker, and they dropped us off on the ice, and we had a Russian with a very high-powered rifle. We were glad he had it, because if you pet the polar bear, it'll be the last thing you do before you earn a Darwin Award. I mean, they are not nice. The reason we want them there is because they belong there. It's because the coevolution of climate and life over the last millions of years has seen these creatures evolve in a really well-balanced ecosystem where they hunt on sea ice, and then they throw these seals around, and they're very sloppy eaters, and then the Arctic fox, another wily creature, and then some much less wily creatures like Ross and ivory gulls have to follow behind them. I don't actually think polar bear is going extinct. I think it's way too clever. It's going to live in the garbage dumps of Churchill. People with money are going to create boutique reserves. It'll be in zoos. What will happen is its ecosystem is already functionally extinct because the Arctic sea ice is unlikely to survive more than a few more decades. What happens when 2 or 3 generations of polar bears have no ice? Is it instinctive how to have this, or is it learned? Well, we're not going to know. We're going to find out. Because one day when we go back and we recreate the original climate, presuming that we do, are they going to know, or is it the system going to go out? Now, how much is that worth economically? How do you weigh that against the improved shipping routes across the melted Arctic sea ice? You can't do that by any known cost-benefit analysis. It's gut check values. It's what matters. And that's a political debate, not a scientific debate. So what I'm going to try to make certain that I also tell you, if you remember, is not just the preponderance, but remember to separate out the components of the discussion that have to do with science. That's risk. Anybody know how to define it? Risk? Right. What can happen times what are the odds? That's a scientific judgment. How about making decisions? That's called risk management. That's not scientific. And therefore, how much of our present resources in a resource-scarce world should we spend on this problem rather than health, rather than housing, rather than defense, rather than national parks? That's a political job where you don't use cost-benefit analysis to determine it. You have the values of society, hopefully through the representatives that have theoretically been elected to represent your values. And I noticed a few cynical smiles when I said that. there are good politicians, not always an oxymoron, and they need value signals from you in order to know how to make these decisions when they get the good kinds of information, which is why we have an IPCC, an Intergovernmental Panel on Climate Change, or why we have the National Research Council doing studies, because there's so many cacophonous claims and counterclaims out there that it's not a very easy job for the public to sort through them, to figure out whether the latest result really falsifies or is itself false. And again, it takes a long time. One last comment on that. That process I told you about, which took 20 years, most science is not Archimedes in the bathtub, eureka, I have it, and streaking through the streets of Syracuse before Ashcroft would have draped him. This is not how we work. Most of the time, scientists get together in the second-rate hotels that we have our scientific meetings in, at dinner, drinking the third-rate wine that we can afford unless I'm ordering it for my students. And then, I will order Willamette Pinot anytime if I can find it on the menu. And then what happens is they say, I got these results, what the heck does that mean? And we work it out as a community enterprise. Science is a community collective. And we work on the basis of skepticism and criticism from which, when you can't find something wrong, you start to evolve belief toward that, and then over time, that belief accumulates into a preponderance. And where the threshold is when you believe it's over better, more likely than not, that's a judgment of the community. So I wanted to spend some time here on the process because that's so critical to the political debate, which is so bastardized by people's claims and counterclaims that the latest single, almost irrelevant detail either accelerates or trumps the result. All right. So with that said, let's go back to the polar bear. So this is the spring and the fall. This is the extent of sea ice in the summer, and it goes down. That is not global warming. That is the normal seasonal cycle. Here it was from 1979 to 2000. Here it is in 2005. There was the record low last year. And despite the fact that there's been a little re-advance of sea ice in the cold 2 months that we've had now, most of my colleagues who do this are projecting this will be another record this year. We'll see. You know, 1 year doesn't prove it. One exceptional year doesn't disprove it. And there's a fair amount of noise from year to year in these records. But this is one of the reasons why the polar bear ecosystem is looking functionally extinct, because that's going to continue, presumably. So polar bears are iconic. As I've told you, I kind of like this picture because it reminds me that it's a species. I think of the book as a book in the Library of Alexandria, and the barbarians are at the gate, but the barbarians are us and our consumptive habits and our population growth. And those combinations, those products, and using cheap, inefficient technologies to get those growth ends that create side effects that can threaten species of this kind. So that's, again, a value judgment about how much you value this versus the growth rate in economy. And those will become real trade-offs. And environmentalists don't like to think of that as a trade-off, just as economists like to think that the value of the polar bear is how many dollars people will spend to see it. No. There are a lot of people who believe that it has intrinsic value. And therefore, we have to have that out as a value fight. Now, if you're an iconic symbol, you also have to get a little bashed around. So the polar bears have gotten some entertainment. I want to know how this guy from the southern hemisphere made it across the warmer equator. And if you can find this on the web, these guys are actually bouncing around, but I'm not cyber competent enough to figure out how to get that on there. Mike, you're going to have to tell me how to do this. You know, how you can load it. This is what I call the victims as villains cartoon. And then one of my all-time favorites, it's pretty new, is this one. The bad news, right, is that the ice cap is melting and it's going to be almost impossible to catch seals. The good news is that if we keep moving south, there's tons of fat animals called humans who can't run very fast. This is called the map of meat. I kind of like that. And as you'll notice that this was a very ecumenical bears because it is both race and gender neutral. So in any case, you got to have some humor. No gallows humor. These things can really get you depressed. But the polar bear, iconic as it is, even if it doesn't go extinct, losing its ecosystem is, to me, pretty bad. Whether that's enough to want to lose a GDP growth rate point, that's a debate we're going to have. Okay, this is a picture of me. The only thing I'm sure of is that when this was taken in 1971, I was young, thin, and had hair. That's certain. And there was my guide. Anybody know what that is? Another iconic symbol of global warming. Right, Kilimanjaro, know what that is? That's right, not an ant, it's a termite mound. And the reason to show you a termite mound is in the guts of termites, a bacteria that are anaerobic, no oxygen, and they take the cellulose, produce the energy the bug needs, and they produce methane, which is a greenhouse gas that has 20 times the absorptive power as a molecule of CO2. So this is to remind us that that's a natural greenhouse gas. In fact, don't anybody tell you the greenhouse effect is your enemy, because if it weren't for water vapor, carbon dioxide, methane, nitrous oxide, the principal ones, this planet would be about 60 degrees Fahrenheit colder than it now is. I guess I should say 61. We've added one lately. But about that. We need it, or we wouldn't have evolved to be what we are. That's not the problem. The problem is what we call additionality. It's the entry into the atmosphere of additional greenhouse gases, especially CO2, water vapor, CO2, methane, nitrous oxide, and new chemicals like chlorofluorocarbons. We add water vapor too, but indirectly by heating the system, and then more evaporates. And that's a big amplifier. So land use can affect this, but methane comes from animal agriculture, rice paddies, coal mines, landfills, and so forth. So there's natural global cycles, and then there's changes. And we have to be quantitative, because the fact that these are natural at the same time they're disturbed means we've got to look at both, and we have to do it numerically. And that's why science is so critical here. Now, how about our iconic symbol? Why is it an iconic symbol? Because the ice sheet cap up there has been coming down, and it's nearly gone. This was a recent data point from Lonnie Thompson and Ellen Mosley Thompson's work. They project it to be gone fairly soon at the rate at which it's disappearing. And I just put this up there. Here's where I was up there in 1971, 2 weeks before my PhD defense. And that's the red line, which does that. But I put the red line up for another reason. First of all, 40% of the cap disappeared in my professional lifetime. This is not all about things that take thousands of years. Climate change can be very fast. That Arctic sea ice is even faster than this. It's very recent and very fast. But that red line is pretty close to where freezing occurs. Above that, it's below freezing. Below that, it's above freezing. And it's been asserted, and correctly, how can the ice sheet be a result of global warming if up there it's still below freezing? I mean, if you took a tray of water that you would turn into ice cubes by putting them in the freezer, and you took them outside when it was 28 degrees, they'd freeze. Supposing it were 30 degrees, you took them outside, they'd still freeze, a little slower. So why isn't the fact that it's still below zero actually adding to ice? Can't be global warming, it's been said. Let's unpack that. I want to show you about the complexity of these problems. Because what happens if you take that tray of ice cubes that you put outside and you put it outside in the shade? It's going to freeze. What happens if you take it and put it in the sun? It's not going to freeze, not till the nighttime. Because it's not about temperature. It's about the energy budget of the ice, the water. And that's a positive, the sunshine heating it, and a negative, the temperature difference cooling it. So if you warm up a degree, that's going to add a little positive into the equation. Now, this is what we call competing explanations. So this is not one of those things that's understood beyond a reasonable doubt, or even where there's a strong preponderance of evidence. But the point that I want to make is the iconic symbol is not absolutely a solved problem yet as to what its cause is, and it's legitimate for scientists to be skeptical and ask these questions, but it is not ipso facto true that because it's below freezing up there, therefore it must be some other factor because it's less below freezing, and that could be a positive factor in the energy budget. So that's, again, how we do complexity in science. We also don't look at one thing. So this is one of about 95% of glaciers behaving this way. So there's a Patagonian ice sheet in 28, and I'm going to show you the after picture, and it's pretty dramatic. This is one of the more dramatic, but most of the glaciers are receding, and most of them are receding consistent with warming. Any one of them you can challenge, just like you did Kilimanjaro. It's very difficult to challenge the preponderance and say this is just a random event. And in fact, the scientific community does not conclude that it's a random event. They conclude it's very likely that it's related to global warming. Okay, Greenland. Anybody flown a polar jet, polar cap jet from Frankfurt or London over to San Francisco or Washington? You'll see this. This is an outlet glacier last September on the eastern side of Greenland, and it's breaking up. Does that prove anything? Of course not. Probably broke up even in a cold period. But did it break up more? Did it break up less? That's what really counts. So this is the picture on the United screen. So that was somewhere over here. Now here we are in the middle of the ice sheet. People say, wait a minute, I can falsify global warming because the middle of ice sheets are increasing a little bit. And they're supposed to be melting. Therefore, you can't say the sea level is rising from ice sheet melts and global warming. Wrong, again, because that's in fact the forecast. The forecast is where the temperature is well below freezing, and it is in the high parts of these ice sheets in Greenland and especially in Antarctica, warming up a degree or two means the atmosphere can hold more absolute amount of moisture, therefore you'd expect more snow. The forecast is for more snow in the high elevations. It's also for more melting on the sides. Who wins? That takes satellites to figure out, and the answer is that in Greenland, the melting sides are winning by a fair amount relative to the building up top. What does it look like when you fly on the top? That's what it looks like. This is not an out-of-focus picture. That's the contrail of the jet. So you don't see very much. But how long is it going to be before that happens? I don't know. Neither does the community. They argue anywhere from a century or so to 1,000 years to start melting that off, or even 2,000 if it's very slow. But once you start the process, it could become inexorable. So what's our fiduciary responsibility to the next 100 generations? Is our behavior to be 500% richer 1 year sooner in 100 years worth taking the risk of this ice sheet? That's the kind of trade-offs that we're going to have to face. And we can't make good decisions till we understand them. Now we're at the other side of Greenland. Now we're exiting over on the west, more breaking up. But again, you have to have a time series. So here it is. This is Greenland in 1992. There it is in 2002, and it's expanded dramatically. Is that a natural fluctuation, or is that due to warming? There are arguments on both sides, competing explanations again. Remember, science has got well-established stuff, competing explanations, and speculative stuff. This is a river in Greenland. It's called a Mulan. Drops down. There are some people who believe they lubricate the bottom. They cause the ice sheet to slip. If that happens, it melts, lubricates itself, and leads to an irreversible process. Is that true? Don't know. It's possible. There are some models do it, some don't. My glaciology friends fight about it. I listen to them all the time fight about it. It's, again, you're taking a gamble with laboratory Earth. And that's the nature of the science. Don't listen to somebody who tells you they're absolutely sure that that's the case, because they're not. And don't listen to somebody who says, well, until we resolve it scientifically, we're not going to pay any attention to it. That's the same as the Tobacco Institute. So here's the most recent picture. This is from Conrad Stefan and colleagues in Colorado. And this one, he said, when I saw this picture, he showed it in Australia about 2 months ago. He used the word that's not too common for scientists. He said, this one is scary. So I said, why is it scary? Is it because it's encroaching further up the ice? And he said, no, the red dots, first recorded melt. So they sunk cores, and they went back over the last 10,000 years of our interglacial, and they found no other year, because you can count the individual snow layer rings, that was melting. That strikes me as pretty strong preponderance of evidence that this is not just a random fluctuation in dynamics. There's still competing explanations, but it's starting to tip. And that's where the community is, and that's how we do our evidence, and that's why we get together in those hotels and why we have IPCCs, because no one person is going to dare to interpret the meaning of this with high confidence without running it by their colleagues. And again, that's how the process works. Now contrast that to op-ed pieces or statements made in front of Congress by those famous professors. Okay, ignore the green for a minute. Here's a big hurricane. I think this was Wilma. This is the intensity of hurricanes in the Atlantic. That's the dashed line, and the black is the sea surface temperature. The theory says warmer oceans are going to cause more intense hurricanes. But there are 5 factors: depth of the mixed layer, height of the tropopause, wind shear. Sea surface temperature is just one. So again, competing explanations. But when you take a look at this, it's not just true in the Atlantic, it's also true in the Pacific. Slightly poorer correlation, but nonetheless true. Therefore, I start to tip my preponderance toward exactly what IPCC said, which is it's more likely than not, sounds like a preponderance, that recent observed increases in hurricane intensity are connected to warming, and future storms likely, which in IPCC, where we do use a quantitative scale, that means 2 out of 3 to 9 out of 10. It's a subjective judgment because there's no data on the future. It's an expert judgment, but a subjective judgment, argued through 1,500 review comments and 3 rounds of review of IPCC to intensify. So that's how we play the game. We get literature, we look at it, we look at the multiple competing explanations, and you try to thrash out the relative credibility of each and assign a confidence. And then you revise when you get new information. So, I'm always asked this by journalists. Is the science of global warming settled, as if without it being settled we shouldn't have policy? How many think the science is settled? How many think the science is not settled? How many think it's a dumb question? Thank you. Because there is a lot of things that are well established, that are settled. There are a number of things that I've just shown you are competing explanations, and there are things that are speculative, like what happens to rainfall in Oregon in the winter. It's beginning to look pretty likely that in the summer it's going down, especially in California, where because moisture is going to go down, because when you get hotter and you don't have a lot of rain to make up for it, it's not a good prescription for avoiding wildfire. We'll get to that. But you've got to separate it out. So here is settled science, 10,000 years here, and these are what we call hockey sticks of 3 principal additional greenhouse gases: nothing, nothing, nothing. Industrial revolution, bingo. 150% increase in methane, 35% increase in CO2. This is beyond a reasonable doubt. It's due to us. Agricultural activities, mostly agriculture and animal agriculture. This is nitrogen fertilizer, and the CO2 is fossil fuel burning and land use change. So that's pretty certain. But how much has that done? IPCC again, warming of the climate system. This is not a standard word. Unequivocal, especially from somebody who's as careful and scientifically conservative as Susan Solomon. She's the woman who led the expedition into the Antarctica in the late 1980s that proved that the ozone hole was caused by human-released chlorofluorocarbons. And Susan was in charge of Working Group 1 of the IPCC, the What Can Happen Working Group. And they said unequivocal based on the evidence I showed you. Now, if IPCC says it, it must be true, right? And here was the press conference. There were 4 of us from Stanford who happened to have been in town that day. I couldn't believe the coincidence of this. This is worth a minute. This is a funny story. Because my wife, who's over there, Terry Root, who's also an IPCC lead author, got a phone call from one of the local TV media guys. And he said, "Oh, Terry, I want to interview you after the press conference." And she said, "This is 9 in the morning. I'm still asleep because I went to bed at 3:30 in the night before, as usual, getting things done." And she says, "What press conference?" And he says, "Stop kidding me. Congratulations, by the way." And she says, "Wayne, what are you talking about? You don't know? You just got a Nobel Peace Prize." So she just laughs out loud. "Yeah, I got a Nobel Peace Prize. Thanks." And she looks at her watch. "This is not April Fool's. Thanks, Wayne." No, Al Gore and the IPCC. Didn't they tell you? And she said, "There are thousands of people in IPCC, and then I got to call each one of us up, So what do you mean press conference? Well, he happens to be in California now, and he's going to have it in Palo Alto at a new place he's starting. And because Wayne's a media guy, he actually had, so we got the coordinates, and Terry said, get up. We're going to the Nobel Peace Prize press conference. And I said, I got to talk to Stanford alums today. I mean, these are, well-heeled people. The president is not going to be happy if I don't show up. And I think she said, are you out of your unprintable mind? This is a Nobel Peace Prize. They'll find somebody else. So she starts calling all the lead authors, and I call the development office to say, I can't abandon them. And she said, listen to your wife. Are you out of your unprintable mind? Go to the conference. So we went off to the conference, and I was starting to feel bad because I know him for a long time. I testified to his first hearing in 1981 when President Reagan's people cut the budget on climate impacts research, and it was his mentor, Roger Revelle, whose program was cut. And so Roger and I went to testify on this, and he got in the game back then, so I didn't think he'd be too mad at me for doing this. But usually you like to ask permission before you show up. So Terry says, so call up one of his staff. I said, I don't know his staff's phone number. I only do it by, by email. And they're in Tennessee. We got to go in the next 10 minutes. So we're driving over there, and I'm feeling a little guilty, and I call my office, and I tell my assistant where we're going and that she should try to get a hold of somebody and let them know we're coming. So we get there, and there are all these cars parked and all these, these trucks with the satellite things. And we can't even find a parking space within 3 blocks. That turned out to be good news, because while we were walking over it, my cell phone rings, and it's a friend of mine who happens now to be on the Gore staff calling from the limo, inviting us to go to the press conference. So that was good, and I couldn't resist. I said, okay, Kaylee, thank you for that, but there were 4 of us from Stanford, and we're looking for parking. She said, you guys are good, Just come in, and we did. And what was really interesting was I was very surprised at what the vice president did. He gave a 5-minute speech. That's not his strength. His strength is Q&A. He turned around and he said, the IPCC lead authors will handle Q&A, and he walked out. I've never seen him do that before. I couldn't figure out what was going on. And most of the reporters left. Maybe 10 stayed, and we had 2 hours worth of very good interviews with people who cared. That's why he left. Because what do you think they were going to ask him? Are you running for president? Who should we have? And he said, this is about climate. Actually, he went up in my mind for that. I thought that was a pretty good thing to do. He said, this is a day about climate. This is not a day about politics. In any case, what I really like about the Nobel story is prizes tend to be media ready, because the media is very big on cult of personality. And so we all, we like to know about people with French names, like Paris or Brittany. I don't know why people want to talk about French places. But somehow they're covering that kind of stuff. But how about covering something real? And the cult of personality is not always the best way. So what was the statement about 4,000 people who've been associated over 20 years with IPCC was a switch from cult of personality to culture of community. And the reason that symbol is so important to me is we can't solve this problem except by community action. And I don't just mean community in a state level or in a national level, but on an international level. Because China and India are saying, wait a minute, you want us to take targets. We're a factor of 5 to 10 per capita less emitting than you are. When we catch up to you, we'll take a target. And we say, yeah, but you're a factor of 4 more populated than we are. If we multiply that times the American standard of living, we have a planetary sustainability train wreck. And quintupling of CO2. So the key is we need the C word, not competition, but cooperation. And cooperation is built on trust, which comes from community. So I really like the symbolism of it going to IPCC. And I thought that was nice, which is why I spent so much time on this, because there's no hope for us if we can't build that kind of community, for which hopefully American leadership will get reestablished sometime soon. All right, why was it unequivocal? Well, there it is. There's the 1.4 degree Fahrenheit, the 0.75 Celsius warming, there's sea level rise, that snow cover decreasing. I did promise you I'd give you a couple of technically complex ones. This one's important. It's worth 2 or 3 minutes. The black line is the yellow line. There's the observed warming. This is 100 years. This is the 20th century up to about 2005, so it's 5 more years. The blue is what happens in 20 climate models when you drive them with natural forces, volcanic eruptions, changes in the energy output of the sun. It gives you a pretty, and by the way, it's 6 continents, global average, global land average, global ocean average. If you get it right on all of them, the confidence that you're going to have that you've got a global signal is a lot higher than if you get it right on only a few. You can calculate statistics on that if you really want to. You don't get a very good fit in South America, in North America, anywhere when you drive the system only with natural forces. What if you drive the system with natural plus human causes? Much better fit. Is this proof positive? No, it's circumstantial evidence. But it's certainly better than a 9 in 10 chance that this is not just a random accident. It's what we call fingerprint. And there are other fingerprints. Stratosphere cooled, lower atmosphere warmed. That's a fingerprint of human activities because if the sun did it, it would warm the upper atmosphere, the middle, and the lower. So when the community makes the assertion that it's very likely that humans are responsible for most of the warming of the last 3 to 5 decades, this is not an idle consideration because very likely means more than 9 out of 10. So that's because you can't get odds like that of all these independent events lining up without having a relatively low probability that it's a random event. So that's the nature of the evidence that you use. So again, is the science settled? Well, the ones I've shown you are pretty settled, but there's plenty of stuff that's not even remotely settled. Standard argument, but it's happened before. I especially hear this from my geologist friends. And they say, 120,000 years ago, 125,000 years ago, it was 1 or 2 degrees warmer. This is just part of a natural cycle. And I said, well, it's really completely relevant to ask whether it's happened before. But is it appropriate to say, therefore, this is just part of a natural cycle? And I like to use analogies. Oh, first, let me show you. This is 500,000 years of data. Ice ages are down here. Warm interglacials are up there. 6 degrees C, 10 Fahrenheit is roughly the difference between an ice age and an interglacial. By the way, when we're talking about 5 degrees warming, that's a big number. 5 degrees C warming, you know, somewhere near 9 Fahrenheit, which is in the realm, as you'll see in a few minutes, of the predictions. That's a temperature difference in an ice age and an interglacial, round numbers, in a century and a half, not in 5,000 years. 5 to 10,000 years to get that melted out. That is dramatic stuff. And that's why you'll find ecologists who see 40% of species being threatened with extinction as an emergent property of that kind of change if it happens that fast. So anyhow, let's go back. If you look carefully, notice this one was a little bit warmer than that one. What about the therefore, the recent warming must just be natural? I have a metaphor for that. The norovirus. Anybody ever have one? Miserable, horrible, stomach flu. I had 102 fever for 3 days, almost had to go to the hospital for hydration. If the logic that previous warmings have happened, therefore current one must be a part of the cycle is true, then it's equally true that all fevers are created equal, and the next time I have 102, it must be the norovirus, right? Couldn't be respiratory, couldn't be kidney, malaria, something else. That's why we do the science. That's why we look for cause and effect. We know that these peaks up here coincide with changes in the elements of the Earth's orbit. In fact, the same models we use to project the future reproduce that. They, in fact, aren't damning the models. They're, in fact, helping confirm them. So we use paleoclimate not as an analogy. There is no analogy. Nobody was putting CO2 up then like we are now. Nobody was doing land use change like we are now. It was a different set of forces, and you've got to drive the models with different sets of forces and ask whether they reproduce something of what was observed. And the answer is it's not a perfect fit, but it's a pretty good one relative to not driving them. The other thing is when people tell you that well, it's been warm before, therefore this is natural. Did they also remember to tell you when it was 1 to 2 degrees warmer, we had 5 meters of sea level higher because most of Greenland and part of Western Antarctica had melted? That's part of the reasons why the IPCC said that there could be meters of sea level rise in centuries to millennia associated with melting ice sheets, because it happened before. That is probably a better analogy, but even so, that's not enough. That's why we don't assign high confidence to that conclusion. That got medium confidence, like half. Okay, so let me finish with some other parts. So here's the decrease in snow cover with warming. Well, that's a surprise. It got warmer, the snowpack in the northern hemisphere went down. So that's certainly what you'd expect. Here's where you run into trouble. If you want to put it apart, you say, wait a minute, from 1950 up until 1990, it went the other way. I have just falsified global warming. Look, the snowpack went up, the ice age is coming. There were even people who said that. It's too short a record. It's just as ridiculous as going from here in the 1980s down. Now, my God, we're just disappearing at an incredible rate. That's noise. To do global climate change, you need to look over a fairly long period of time, especially at noisy records. This is not a made-for-media problem, not because it's very hard to get people to pay attention to that. But that's not what I want to really talk to you about. I want to talk to you about, is it good or bad that the snowpack is going down? So I gave a talk a year or so ago in Colorado, right after they'd had the airport closed for 4 of 6 days. And much worse is they had their kids home from school during the week, which they didn't want at all. And several people said, maybe not having so much snow, well, maybe that's a good thing. And others said, what are you talking about? We need it for the ski industry and the ecology and the water supply. And immediately I'm listening to this debate among stakeholders, and that's exactly what you have to expect. There's no such thing as a change that won't have some people who like it and some people who don't. And you have to expect that. And that's why you adjudicate these things in the political process, because you cannot expect all people to agree about all things. So, this was supposed to remind me to tell you that not all things are bad, right? Good news is at the rate of current warming, we'll swim over there and eat him in under 5 years, right? Of course, there are a few things wrong with this cartoon. A, it takes sea level a century to go up 5 meters. A meter. B, I think he's in trouble on any storm surge. C, he's not going to get by with that resource base. And D, only about 10% of large fish are left in the sea, and the probability of these guys surviving 5 years is lower than his not. But in any case, it still reminds us there are pros and cons. Okay. So why do I show you a cruise ship? Not to talk about the norovirus, but to remind us that the cruise ships and the shipping industry is thrilled that the Arctic sea ice is melting. So are the Russian admirals. You know, historic warm water ports. What about the Inuits? They're suing because their culture is being destroyed. So if you're doing cost-benefit economics, hey, we got tens of millions of dollars benefit to the shipping industry, maybe oil exploration. What's the value of a destroyed culture? Well, you can't treat it by any known quantitative metric. It's a political value choice. It's gut check time. Same thing for the polar bear ecosystem. So what makes this problem prototypical and a challenge to functioning democracy is you're not going to have it in monetizable commensurate units for which the classical business solution of cost-benefit analysis works. And that's where you need humanistic studies. And you need other people to figure, what do we value? How do we do it? Well, why is it that the 3 Western states have an alliance of governors? Because in a Mediterranean-like climate where it's dry in the summer and wet in the winter, which we all have, if you crank up the temperature when it's relatively dry in the summer, you substantially increase the risk of fires. In fact, there's been about a 4-fold increase in Western fire in the last 30 years. Is that all climate change where it's warmed up by about 1 degree? No, because people have moved houses where they don't belong. People have fought fires and let the underbrush build up, and therefore when you get a next fire, it's a doozy. So like all else, it's competing explanations. Some of this is climate, some of this is not. How exactly to separate them out is not so easy. But it sure got the attention of the California governor. And California, as you know, said, well, we need to have 80% cut in emissions. And that was very surprising coming from a Republican. And I testified to the Ways and Means Committee last year. And one of the Republicans asked a perfectly honest question. He said, how come you guys in California have a Republican governor and a Democratic legislature, and you're actually able to get along? And I said, well, that's because there's no such thing as a Democratic wildfire or a Republican drought. You know, we have a common enemy. Could you guys do the same thing, please? And they actually are. It's a historically better place for this issue now than I have seen since that hearing with Al Gore in 1981. It's been that long since we've had cordiality and bipartisanship on this issue. So once we change the presidency, we'll have real policy. And that's pretty soon. Any one of the three leaders all agreed that they're going to do something about this. So let me conclude. Let me jump ahead to something. Nope. Take 2 seconds. The one thing I hate about PowerPoint is where did I want to go? This is where I want to go. Okay. So let's end up with the management part. Tons of CO2 emission per capita. World, yeah, right. You're reading the graph, are you? California, Oregon's close. United States, Texas. Okay. By the way, Texas is not the worst state. There's one state that's even more. Wyoming. But that's not fair because this is per capita. When you divide by 0, you get a very big number. So for a state with a lot of population, it's Texas. Now, what's the difference? Some say, oh, it's the climate. You know, they have more air conditioning demand and all that. But there's some truth in that, but not entirely. We have more transportation emissions than they do because of our lifestyle. The main reason, very bluntly, is it's a different political culture. California has a culture of rules, of social benefit is worth having protection. Texas has a culture of entrepreneurial rights, trumping performance standards and constraints on individual activity. There's no right or wrong there. Those are cultural / political attributes of different values. The U.S. is somewhat halfway in between. And when there's federal rules, it's going to apply everywhere. Right now, there are 20-some-odd states with these rules. There are many cities in Texas that have decided not to go along with the state regime and that are actually having climate policies. And that's, you know, even Amarillo, in places you wouldn't expect. And that's because at a local level with neighbors, it's amazing how neighbor and neighbor can really get something done that's tough to do in a legislature. And so we need to work every side. But that's all part of it. Now, why is it that California gets away doing that? Well, this is California's 35-year history of rules, appliance standards, refrigerators, air conditioners, toasters. Now, TVs have to have shut-off power supplies, a number of things. Industry screaming and yelling how this is so unpleasant for them. And of course, then the answer is that don't sell in California. Your products are now illegal. And they all fix it, and they all fix it cheap. So they spend $2 a unit fixing it, and they charge $7 more a unit, and they're all better off. And building standards and utility efficiency programs. Again, I had to talk to the guys in Ways and Means, and I use this as well. 15% of California electricity, which is 40,000 that's billion, watt hours at 15 cents a kilowatt hour, so not even high at peak times. That's $6 billion a year. Hey, Republicans like $6 billion just like Democrats do. So it's not hard to get performance standards legislation through the California legislature or through the Energy Commission. When you use payback criteria that are what I call 7-11, better than 7% return on investment, that's better than mortgage interest rate for most people, or less than 11-year payback required by law. If you don't require it by law, people won't do it. They don't know about it. Builders don't encourage it because they don't want to have slightly higher prices in their bids. They're afraid they'll go to somebody else. So it has to be part of the collective protection. And again, so this problem raises the specter of a debate between private rights and public protection. Now, if you think this is unique to this problem, go back and read Locke, Hobbes, and Rousseau about the social contract. There's absolutely nothing new here. What's new is the scale is planetary and the consequences are 100 generations. So I think that actually makes this problem a little more prescient because you have a lot of potential irreversibilities. So the bottom line then, is this is an economics picture. This is cut tons of CO2. This is how much it cost. This is negative. In other words, building efficiency, transportation efficiency, and industry efficiency actually pays you back faster than the normal return on investment that they get. So it's negative cost. This is not done by Enviros. It's done by McKinsey with some help with one Enviro group, NRDC. And then this is positive. These are real costs. That's renewables, other kinds of energy, carbon capture and storage from coal plants and other innovations. I don't like this figure a lot because it has solid boundaries. I believe each one of these is a bell curve that allows some slop over the line and some even better, just as I think investments in research and development can pull these numbers below zero. But if we're going to have a learning by doing feeding frenzy where we're going to try everything, we're going to get solar thermal and we're going to get batteries and we're going to get DC transmission on wind, you might even try to get the nuclear industry to do it safer and cheaper. I mean, there are a range of issues. Whatever you want to do, it's not going to get cheap until you deploy. It is not R&D that matters, research and development. It's R&D. It's the second D, deployment and demonstration. We've got to build to scale. How is that going to happen? You don't get return on investment without investment. You don't get investment in a risky market. So here's where we need the government in the act. The government is the last people to ask to build the technology. That they're not good at. That's the private sector. But they need to provide incentives for investors. Maybe it's loan guarantees. Maybe it's performance standards. Maybe it's taxes on the polluters. There's a range of ways you can put an investment. So you invent your way out of the problem by having sensible policies. So when we say, as in the title, can we manage the risks? There's two strategies. One is you have to, in fairness, help the people who are hurt by the climate change in the pipeline. And I'd say we've had 1.4 Fahrenheit. We're going up at least 2 more. I don't see any way that it's less than that. There's too much inertia in the system. That's going to cause some damages in Hurricane Alley, in fire-prone West, in the Arctic, in droughts and floods. So we need to get some relief for people who are hurt by that, especially in the developing world. So that's adaptation. But what all the literature shows, it becomes very difficult to adapt when you warm up more than in C, about 2 to 3 degrees, in F, 3 or 4. Most of the projections for the future show warming, if we're lucky, another 1 to 2 degrees C. Unlucky, oh my God, 4 to 6. So we have got to do everything we can not to let the 4 to 6 happen, and to deal with adaptation for the 2 to 3, because the literature also suggests that it's very difficult to adapt, both natural and human systems, for very large changes. So don't let anybody tell you adaptation and mitigation are trade-offs. They're complements. You've got to do them both. And that means you've got to have 2 good acts of governance. You have to deal with adaptation, which is fairness to people who are losers, and you have to deal with mitigation. But you actually need a 3rd act of good governance. If you're going to have a shadow price on carbon, and you're going to make conventional energy more expensive, people who make the Hummers and who mine coal are in some trouble. So are you going to hold the sustainability agenda of the planet hostage to their kind of work? I hope not. On the other hand, you're going to cast them out in the street like we did the railroad workers who shoveled coal and steam trains when diesel electric came along? I hope not also. I hope we're fair enough that we can also provide some transition strategies. And that analogy is going to have to work with China and India and Indonesia and Brazil and Mexico and other countries, because they're not going to agree to just say, no, we're going to forego the Victorian Industrial Revolution and sweatshops and coal burning and high technology, because that's what we used to get rich, and now they see this as a plot against their catch-up. So if you expect them to take targets, as I hear from our administration and a number of other people, Well, we're going to darn well have to help them to leapfrog over the Victorian Industrial Revolution to solar thermal and to fuel cell cars and to electric fleets, and not into the same technologies that we used that can't be multiplied times another 4 billion people and expect there to be a safe future environment. So all of those things involve the two good acts of governance: protect the commons and be fair. Because without both, it's pretty hard to get there. We haven't had the capacity to get one until recently. Now I am hoping that we'll have the capacity for both, and we need all of your help, and thank you very much for listening. I'm told that we're here till 9, so that leaves 20 minutes for comments and questions. There are microphones if somebody wants to walk up to them, because it'll be very hard in a room of this size. I know some people have to go. So while the people who are going, those who want to comment or question, why don't you walk up to the microphone and we'll take it. You should probably please say who you are. People always like to know who it is that has such a good comment. So.
Thank you very much. You're fantastic. Love your thinking.
Thank you very much for that.
The big question to me is, how do we wake ourselves up and wake up the mass consciousness much more rapidly? Because what you're addressing, to my mind, is what I call implementation rate, what Bucky Fuller called lag time. I was the science advisor for 2/3 of the churches in Oregon on global warming, 2,000 churches. And there's a very brilliant man on campus, Paul Engelking, physical chemist, past president of Oregon Chemical Society. Brief conversation I had with him demonstrates, I think, where we need to go and where you're going to. In 1992, a crucial thing happens, and it should be on everybody's mind every time we think about global warming, and it was like mentioned for a couple days and it's gone. Here it is. Scientists studied the tundra in Alaska. 40% of the world's methane is thought to be in the world's tundra. You know better than me. What they found out is in 92, the Alaskan tundra went from being a net methane absorber to being a net methane emitter.
Right, Siberia too.
Right. That got Paul's attention. He's a strong man, never saw him quake before. What that means is the thermal flywheel on the planet was reversed that year. Everybody should know that. These are what I call, is my word for it, deep cycle megatrends. You showed some too. You showed the red dots on Greenland where there'd been no melting for 10,000 years. That's a deep cycle megatrend. That's not popcorn. When you see the hurricane levels going up, we should think about deep cycle megatrends. Why? Because there's this misfit between social psychology and what the physicists, biologists know, and it's this. We're rewarded personally, professionally, financially for being what I call, another one of my words, social hydroplaners. In other words, like Charlie Tart says, UC Davis, we're in cultural trance. We are not rewarded for stepping out of cultural trance, personally, professionally. We got to get out of cultural trance. And when enough of us see the deep cycle megatrends, we'll say the time to act is now. And so we got to look at those deep cycle processes, put them together, and say the time to act is immediately, because we don't have any time anymore. And so if we could think in that way, what are the deep cycle megatrends? How can I get out of the cultural trance? So what are the things that you see among your fellow scientists where there's a greater ability to integrate the patterns of the deep cycle megatrends to get us out of that trance?
Okay, well, thank you for that comment. Let me say at first that I completely agree that looking at long-term trends that have very, shall we say, dangerous implications helps. But I found that it's hard to get the public or the media and even members of Congress motivated on that. You know, they tend to be much more motivated by a Katrina. And the underlying megatrend you're talking about is the buildup in the ocean temperatures in the Gulf, and therefore the creeping incremental increase in the average intensity of hurricanes. But it so varies from year to year that you lose the trend, which is why those trends are hard to get people motivated. So the big problem is if the motivators are the short-term catastrophic events, But nobody is going to claim that Katrina was global warming, only that it was souped up a little bit. Then you almost deny your own capability to be effective, but we got to tell the truth. So the way I try to frame it is I would say that I don't know whether 3 inches or 3 feet of Katrina's storm surge could be attributed to the half-degree warmer Gulf of Mexico. 3 inches, it probably didn't make any difference. 3 feet, it may very well have been the reason it knocked down the wall. So there are thresholds in our vulnerability, not just thresholds in nature, for which if you keep creeping up the trend, it takes it out. Remember, if you have a castle that you build on the beach, you know, where the kids love to build these things, and they try to hold back the sea, they make them bigger, the individual waves that come by are just random gusts of wind driving the waves. But the tide, that's the long-term trend, eventually swamps you out. So you can use metaphors to get people to understand trends, which would be how I would do it, but you have to be careful not to overclaim any one event, because it's the biggies that get the media, not so much the trends. Then we have to link them without overstating it. And that's a pretty tough job to do when you're doing it honestly, when other people out there are saying, oh, well, look, we just got this negative mega trend, and therefore we've just trumped it. So thanks for that. It's not easy, but we certainly have to point it out. Next person, please. Thank you.
Ruth Demler. My question is, politically, I can't see it happening, and I don't hear it mentioned at all, is lowering the speed limit. If we lowered the speed limit to when it's most efficient for an automobile, about 45, 50 miles an hour, I understand Washington State is doing it for another reason, to keep the flow of the traffic. That also would help. Do you think anyone politically could ever mention that?
Part of this transportation below zero cost reducing at gaining dollars was including driving, not even lowering the speed limit. Let's start by obeying the speed limit. Because people are driving 10 and 15 miles an hour over the speed limit, and that's up at the 80, 85 mile an hour level. The air friction is very significant. The car's efficiency at 85 miles an hour is a lot worse than it is at 70. So at least let's do that first. And then that also is why it's cheap, because you save yourself gasoline, you save yourself wear and tear on the engine, because you're not running the cycle so much, and you're also reducing air pollution. So yeah, that's certainly one, but you also have to do other things. You have to put the cars on a diet. You've got to change the power system to have a lot more electric in them. Whether it's going to be hybrid, plug-in hybrid, all electric, I think that's going to depend upon that learning by doing feeding frenzy, where we've got to get the batteries invented that are a lot better and cheaper than the ones we now have. But if you start building at scale, you've got a chance for invention. So thanks for that. And there are so many things to do. That's getting your house with the proper efficient windows and lights. The next time you replace a refrigerator and air conditioner, please look at the label. You know, things like get the one that has better energy. All those little things, when millions and millions of people do it, actually add up. Yes, please.
Thank you, Jackson Kellogg. I have a quick question. We have millions of people living at sea level or very close to sea level, and I think that a 1 or 2 degrees Celsius change in the global temperature will have an effect on the sea levels potentially. How do you talk about that, and what do you think the sort of least worst case scenario is? Okay,
the projections for sea level in the future depend upon 2 things, well, 3 things. First, what scenario you're on. Are we going to be only increasing CO2 by 50% more? Very unlikely we'll be that lucky. We got to work to get that, that's for sure. That's sort of the Schwarzenegger 80% cut by 2050 would be an increase of about 50%. And the second thing is, how sensitive is the climate to any increase in greenhouse gases? That's called climate sensitivity. We have no control over that. We just don't know the answer to better than a factor of 3. So if we're unlucky, it's going to be very difficult to keep it to 1 or 2 degrees no matter what we do. If we're lucky, we can keep it to 1 or 2 degrees. The amount of warming really affects sea level, because you know how the thermometer works, right? They say the mercury is rising. Well, it's a fluid. So if you heat the fluid, it expands. If you got a tube, it goes up the tube. Well, seawater is also a fluid. If you heat it, it expands, and the tube is the continental shelves. So as a result of that, it goes up. But it takes 500 years for the heat to mix through the oceans. So what we've seen now, you know, the 10 to 20 centimeters of sea level rise is mostly due to thermal expansion of the oceans, which is confined to only about a quarter of the oceans. So we've still got a factor of 4 to increase that when the oceans mix. And if we warm up another 1 to 2 degrees on top of that, we've got another factor of probably 3 to 4. So we're looking at a few meters of sea level rise pretty much no matter what we do, and that's at the lower end. But that could take 2 centuries to happen. So it all depends upon whether you believe in discounting as to whether that has any present value. So one more thing, and the third factor is what happens to Greenland and West Antarctica. Because if those start to go, then all bets are off, and we're looking at meters of sea level rise in centuries, which is what my chapter in IPCC said. Working Group 1 only talked about 50 centimeters because they said, well, we don't have a really good basis for projecting what will happen to glaciers. All we know is that the models have underpredicted what's happened, so we throw our hands in the air and we don't know. And my chapter, which was looking at risk management, said, well, we have to look. So we looked at surveys of glaciologists and we looked at historic data, and we concluded that it was legitimate to say that there was a, you know, more likely than not chance of meters of sea level rise. So I would say that on the time frame of centuries, I will be very surprised if we don't see somewhere in the 4 meter sea level rise range. It just may take a while to happen. Does that answer?
For 1 century.
No, several centuries. What's the fastest it could be in a century? Oh boy, now you have to start looking. You'd have to be really surprised. You'd have to find out that the deglaciation of, say, Greenland is going to go at a much faster rate than any of the current theories suggest. Do I rule that out? Certainly not at first decimal point. I wouldn't rule that out at a 10% chance. And I don't particularly like taking 10% chances with planetary life support system. In fact, I had economics colleagues said, you mean you say there's only a 10% chance that we're going to get the really big sea level rise, and you want to deny the Chinese and the Indians a chance at equality, and you want to unemploy the coal miners and put their daughters in poverty? And we went through all this, and I said, you know, I remember this was we were having salmon that night. And I said, you know, there's only a 10% chance of salmonella in the salmon, so you're going to eat it. You know, and people laughed a little. And I decided that was pretty lame. I can do better than that. And then I thought up the next one. In fact, I'll do it with this group. I said, okay, how many of you have had a fire in your house? This is a large enough crowd to get some statistics. Yeah, a couple of percent. Very normal. How many of you have fire insurance? Fools. I mean, it's way less than 10%. So the point is, you have a 10% chance of a serious outcome like multi-meters of sea level rise. I wouldn't just say, oh, well, that's not very large. That's pretty large. You know, if you had we're buying insurance for a few percent. What's the probability that the scenarios that they run at the RAND Corporation for all the various force structures that we have in the military for every conceivable threat is more than 0.1% probability? And by the way, I'm glad they're doing it. That's risk management. That's what the corporate world is really good at. They're good at hedging. So if we would borrow some principles, we'd get there. And sea level is actually one of the driving forces behind people saying, hey, risk management says let's not go above 2 degrees, please. Have you been waiting?
Yes.
Yes, okay, let's go over there. In fact, some people there might go over there and we'll get an even number. Go ahead.
Thank you for your time. It's been very enriching, and I'm hoping you'll allow me to continue enriching myself and those who are here to continue enriching themselves from this presentation by perhaps giving the presentation slides to be made available by the university, or perhaps footnotes from the slides.
Ask the organizers. That's fine with me. Just remember, cartoons are privileged. I can show them in an educational thing. I don't know whether you could put them on a website or not. You'll have to figure that out.
I think they help for me as a memory cue. And I would be fine if there was a large watermark over every image, or even to be able to track them down. Even like the photo of you with Al Gore there and the people giving you the award, that sort of thing. It was interesting to me.
It'll be there. I have no personal objection to them being put on your website, so I'll let the University Humanities Center decide what they want to do.
My name is Vince Schwent. My question involves around peak oil and resource depletion and how that interacts with climate change. As you probably know, but many people don't, global peak oil production probably occurred in 2005, 2006. Natural gas peaked probably within the next 10 years or so, and there's mounting evidence that even global coal production will probably peak in the next 20 to 50 years, not 200 years as is generally posited. And Richard Heinberg has mentioned that there seems to be a natural alliance between people concerned about global climate change and people concerned about resource depletion, but that alliance hasn't happened yet, because it's in both groups' interests that we try to slow down and spread out our consumption of fossil fuels, which of course solves both problems.
Right.
Just your thoughts and comments on how there could be better
Sure.
alliances.
Actually, that alliance is starting to happen in the Senate. If you read the rhetoric from that select committee, and the bill, the Lieberman-Warner, they actually, I think the title was Climate Change and Energy Security. So that's not a bad place for the alliance to start. You know, we certainly need to have it there. It's a welcome change from the wars that we've been having since '81. There are, other strategies. You mentioned peak oil. Let me tell you that I'm worried less about. I'm worried a lot about peak oil not happening, that it won't peak, because what's going to peak is petroleum, because that's what we're going to run out of. Oil doesn't have to be mined from petroleum. Oil can be made by tar sands and by coal and by other kinds of oil shale rocks. Each process that I just mentioned produces a lot more CO2 per barrel of oil than just using the oil directly. In other words, it would be vastly worse than what we're doing now. So my biggest fears are not on peak petroleum, it's on peak oil not peaking, because we'll make the world safe for Hummers, and that's a significant risk. So we're going to have a very good shadow price on carbon, a cap and trade or a carbon tax or something, to discourage that kind of highly emitting production, unless they can figure out how to sequester the carbon underground. And there was a project that was a public-private partnership, just what I was calling for, called FutureGen. And the Bush administration went to Bali and it said, the US is going to invest billions to invent our way out of the problem. Fine, go ahead. And when people said, what do you say to that? I said, I'll believe it when I see the money. So now FutureGen was going to have a $500 million price tag for the US government, and what did they do? They just pulled the plug. And when somebody said $500 million is too expensive, I reminded them that's 1.5 DIWs, Days of the Iraq War. So is that really too expensive? So they gotta mean what they say, and we have to do these things to make certain that if we're going to go solids to liquids to replace them, then we won't peak. Then we're in worse shape than we were before. So we've got to make certain that those processes are not just dumping in the atmosphere. So all of that's going to require a lot of vigilance. Sir.
Two questions. One, I recently read in Scientific American in January a solar grand plan, and the numbers there look very optimistic. And also, when I put into a search engine global warming and Plan B, which is like solar reflectors up in the atmosphere, that those numbers also, these preliminary numbers also look very optimistic. And so I was wondering, as my first question, do you have any thoughts on those? Should we have a lot more research than they are doing right now in those areas?
Okay, I thought you said there were two. One is how are solar machines, which would be direct production of, say, electricity rather than coal. And the second is, what about what we call geoengineering, dust in the stratosphere to reflect, did I get that right? Reflect away radiation that would exactly balance the heat trapped by CO2.
And others, if you put that in the search engine, but that's basically the idea.
Yeah, so there's basically two questions there. I like the first one a lot more than the second one for a reason I'll explain. The first one is we have to, as I said, invent our way out of the problem, and the only way we're going to be able to avoid dumping in the atmosphere is either you're going to dump all the CO2 underground, and it's not at all clear we can do that at scale. That's going to be a big R&D project. We're not even funding it. So we have to invent some other ways, and I think solar thermal means heat, not just photovoltaics, which tend to be niche applications, The thermal is the ones that could at scale, meaning at very large scale, give you some capability of competing with coal. It's not going to happen immediately. It costs probably $100 billion, over in every couple of years to put them in. It's not automatic, but we got to get going on that one. As far as geoengineering is, people say, well, wait a minute, let's take the guns of the battleship Missouri, take them out of mothballs and shoot dust up in the stratosphere. It's much cheaper than carbon taxes or building solar thermal plants. There's a big problem with geoengineering, or mirrors in space to reflect the sunlight away. It's not that it might not work. I actually think you probably could make it work. Imagine it's social control, basically. It's a great humanities center question. Imagine if 100 years ago the world were as technologically advanced as it is now, and that we knew that we had this serious problem and that we had to try to control climate, and we didn't want to pay the price of the technology investment, the abandonment of traditional energy systems, and we turned to geoengineering. And what happens in this thought experiment is that absolutely the identical politics of the 20th century takes place with strikes, malevolence, world wars, and a Cold War. What would have happened to the climate controllers? They would have been out of business for large blocks of time, which is even worse climate change than trying to control it. So the reason I'm hesitant on the geoengineering side isn't so much the technology, but do we really want to create a situation where we have to trust a cadre of controllers at a time when it requires world agreement and world peace? That's what makes me nervous. My own view is we've got to study it. Because if it's really true that we could drive 40% of species into extinction, and if it's really true that we're just not going to wake up and not going to get it, we may have no choice but to consider these things 50 years down the line. I sure hope it doesn't come to that. The analogy I use is I call it planetary methadone. If you're a heroin addict, the right thing to do is go in the hospital, go cold turkey, get therapy, and get fixed. If you can't do that, it's better than beating people over the head in the streets just to get methadone. So I couldn't ever argue that you shouldn't study it. Yeah. And in fact, I've written a whole number of papers and published them in my journal which make that argument. Not one of those papers suggests it should be deployed at scale. For everybody agrees there are social problems in deployment and technical problems in finding out whether it would really work or overwork. But you can't throw it out. So certainly not the R&D. Yes, sir.
Hello. It looks like we'll want to maintain lifestyle, and that will require building all the tools, the solar panels and everything, and that's going to take fossil fuel. So my question is, do you have any sense of what kind of feedback that might be that's going to take fossil fuel over and above what we already spent to do all this, and what kind of feedback might that be compared with some of the other feedbacks like methane clathrates or such like?
Well, I thought there were two questions sort of embedded in there also. One about the fossil fuel subsidy to whatever you build, and the second one is what about feedbacks? Well, there could be feedbacks on, there's a lot of methane stored in basically what's an ice matrix under high pressure. And if you warm it up, it might actually come out. Most of the people who've studied it suggest that that's a very long-term process. I don't know. I'm a little less worried about that one than I am another one, which is very similar. Somebody mentioned the tundra. That's certainly one. Another process that I worry about is the forests. Right now, tropical rainforests, for example, are not counting the deforestation, which is a source of CO2, but the forests that remain are soaking up some of the carbon. The contrarians, denialists, whatever you want to call them, are always quick to point out, oh, CO2 is plant food. And it is. It's also weed food, but that's another story. And it's also ocean acidifiers. That's yet another story. I didn't go there at all, but that's another big problem. So if CO2 is plant food, isn't that a good thing? Well, it turns out that that's only of trees. It's not of a whole ecosystem, because there are bacteria in the soils, just like the bacteria in the guts of termites. And those bacteria convert the dead organic matter to CO2, and that's part of not net primary production, but ecosystem production. So if you warm up the overall ecosystem, including the soils, then you have two directions of feedback. You have a negative, a stabilizing feedback where the CO2 is going in the trees, but then the bacteria in the soils are working faster because the warmer they are, the more they're going to do their work, and therefore they're dumping CO2 out. So who wins? At the moment, it's probably the ecosystem as sink that wins. But if you warm up, and nobody knows the threshold for this, probably varies with what kind of ecosystem, somewhere between 1 and 3 degrees, 4 max, it switches from sink to source. So then you have a possibility of adding another 40% more CO2 in the system, plus you do great damage to the ecosystems that we need for preserving biodiversity. So these feedbacks are really critical. The trouble is, there's no experiment on it. So it's really flying blind. And it's another reason why a lot of us say, can we please not perform this experiment on this life support system? 2 more, and then we'll have to stop. Oh, okay, we have 3. Yeah.
Sorry. My name is Ariana. I'm an environmental science student here, and I am wondering what you see the role of a scientist being in this entire mess in about 10, 15 years. What do you think is the most productive thing that a scientist could do?
Well, I think scientists, first and foremost, when we're in our stereotypical good guy mode, are people looking for the truth. We want to sort out risk. What can happen? What are the odds? The tougher question, and I talked about this with some groups yesterday and today, is do we have an obligation to go beyond just producing the information and writing it in an IPCC? Should we actually have an affirmative action policy to go out there and alert people when there are risks? The problem is once you go out there to alert people that there are risks, you're generally making a value judgment about what you fear and what you want to do to manage it. I personally don't believe a scientist advocate is an oxymoron. I mean, I think that you can do it, but you have to do it carefully where you say, here's my science, what can happen, what are the odds? Here's my worldview. My worldview is when 20% of the world's population, us in the OECD, are responsible for 75% of the accumulated greenhouse gases, and that poor people in hot countries are hurt more than rich people in cold countries, that's a priority for me to invest in preventing it because that violates my notion of ethics. And when I see irreversibilities, like species extinction, ice sheets that take 10,000 years to come back, which is effectively infinity for human civilization, that gives it special bump for me to want to work on that problem. I always admit that that's a worldview, that's my values, and I will argue like hell to try to get them to pay attention to avoiding irreversibilities and dealing with the equity. I told you that earlier, why you had to have side payments to losers, not just of the environmental change, but also the policy. So I think that's a perfectly legitimate role for scientists. Not all my colleagues agree. Many of them think that as soon as you cross over the line and have a personal opinion about what to do about it, the other side, the advocates, which are deliberately spinning for client interest, will presume you are too, because they are, you must be. And that's a risk you can't avoid. You just simply point it out. So I think more scientists in 15 years will be taking that risk than now, because there are dramatically more now than there were when I started doing this in the early 70s, when it was almost unheard of. So we're progressing that way, but scientists who do it and don't admit it's a worldview, we have no more right to claim credibility for a personal value judgment than any other citizen. We do have a right to claim more than an average citizen for risk judgments, not risk management. So with that separation, I hope that we get more people doing that. Yes, sir.
My name is Milton Takei. All these people in India and China who are burning more and more coal and driving more and more cars, well, they want the same lifestyle that we have here, and can't really blame them because
That's right.
they're no dumber than we are. But the problem I see is that for them to achieve even a little bit of equality, a little bit of social justice, it means that our lifestyle here has to decline in the sense of the amount of consumption we do. And so the problem I see is that people generally don't want to hear this. But as you mentioned, we have to tell them the truth. So how do we convince them that they have to make sacrifices in order to prevent this kind of catastrophes you were mentioning today?
Well, certainly wasteful consumption has to decline. We don't need energy. We need energy service. We need light, we need heat, we need transportation. We don't need 6,000-pound vehicles to drive to the supermarket in if you don't live in a climate with 3 feet of snow. So the first thing that we have to do is we have to be much more efficient in our consumption patterns. We have to plan our days better. So I think that there's a lot that we can do. Whether it actually means reducing the overall service, that's going to be a tough one. You're absolutely right. On the other hand, the argument is made that we have to make room for the developing countries who haven't had their share of the atmosphere to get it. And I keep arguing, well, they can't use our old-fashioned techniques. It just doesn't equate. You start multiplying that times their population size, and you've got CO2 tripling or more. So what you have to do, as I said earlier, you have to help them leapfrog over that. So we have to reduce wasteful consumption and move toward high technology, and we have to have them jump to it even faster than us for that to happen. By the way, there have been a lot of economic estimates of what that costs. Oh, the typical estimate, this is what I call the Carl Sagan problem, billions on trillions. Trillions of dollars is the estimate. 2% of GDP will be lost every year between now and 100 years from now. That sounds astronomical. The current economy is 50 trillion. If it's growing at 2% per year, which is the current growth rate in the planet, it's actually higher than that. That means the future economy is like $400 trillion. 2% loss is 8 trillion. It seems completely outrageous. How can we afford it? But if you're growing at 2% per year in the economy, then you make up that 8 trillion lost 100 years from now in 1 year. So that means you're 500% richer in 2101 with 400 parts per million CO2 and a degree or two warming versus being, yeah, that's right, versus being 500% richer in 2100 a year earlier with 800 parts per million and all these risks. So I keep arguing we can afford to make these $50 billion annual investments that we need for sustainable development and sustainable technology, both at home and abroad. And people are so stymied by those numbers, but those numbers are not a large fraction of the growth rate in the GDP. And I have personally failed to reposition this debate away from absolute numbers toward delay time to a given level of wealth, because I keep getting told by my media friends it's too technically complex. Last question.
Sure. Yeah, I have been kind of watching the biochar soil science issues, and I'm just wondering if you have any comments on that as a mitigation method down the road, especially considering some of the new stuff that Hansen has been doing and various other people suggesting that actually we're further down the line of positive feedbacks than we'd like to be.
Well, I don't know how far down the line we are in positive feedbacks. I tend to frame it as I'm not going to get into a large argument about precisely what the probability of those is. All I'm going to say is if it's first decimal point odds, are we out of our mind taking that risk? I keep arguing that all the time just to get, as I said, 500% richer a year earlier in 100 years. It seems insane, frankly, in my value system to do that. But there was another part of the question I didn't answer.
Basically, biochar as a mitigation strategy.
Bio stuff. Well, there's a whole group of people that are advocating that we should use biotic offsets. You just grow stuff and you can either turn it into fuel or you can just store it away. Some people have said grow the trees and drag them to Antarctica where they won't decompose, bury them underground. There are a lot of schemes that people have proposed. They may even have some bump, with other things. I'm very personally nervous about this quick flight to corn ethanol, because when you take a look at the whole system, including the runoff, boy, that one doesn't look very good. Cellulosic with switchgrass, maybe it's better, but I heard some strong advocates saying, we're going to cover the whole high plains with switchgrass, and we're going to do this, and it's only going to double the price, and that's not that bad. And I said, well, what are we going to do with 20,000 species of plants, animals, and bugs that happen to live there? Oh, I'd never thought of that. You know, maybe algae will be a good solution. You can grow it in scummy places, you know, and all kinds of other bad spots that right now really aren't threatening, and you don't need the fertilizers. And so I think that we could probably look at biofuels, but we have to look at it very carefully.
The char idea is a little different than the fuels. It's that you basically don't burn it entirely, but turn it into
charcoal?
To char form, which then has a long residence time in the soils and actually builds soil rather than destroys soil.
Yeah. Well, there are all kinds of ideas, and you know, I'm not big into quoting President Bush, but Bush 1 said, let 1,000 flowers bloom. I'm not ready for 1,000, but I'd like to see about 50, you know, and I think we have to look at a lot of things, and I wouldn't write that one off either. The question is, we've got to get on with that. We've got to get that $50 billion a year spent. We have to start getting the investments done so that we can have the learning by doing that's essential if we're ever going to solve the problem. Thank you all.
Web address, and this lecture will be available digitally within a week or two. Thank you very much.